If I told you the Romans had the internet, you'd laugh. But they had something eerily similar, and 12 other technologies that make our smart devices look primitive. The most shocking part? We actually downgraded after Rome fell. Ready to feel embarrassed about living in the most advanced era in history? Let's see what we really lost. When the Romans needed to bring fresh water to their cities, they didn't just dig wells and hope for the best. They built some of the most impressive engineering marvels the world had ever seen. Aqueducts that carried water across impossible distances using nothing but gravity and genius. These weren't your average garden hoses. We're talking about stone and brick channels that stretched for over 50 miles, crossing valleys and climbing hills like ancient superhighways for water. The Romans mixed their own waterproof cement that was so good it put some modern concrete to shame. No electric pumps, no fancy machinery, just pure physics and determination. Here's the crazy part. They managed to raise water to multi-story buildings, fill massive public baths, and supply countless fountains throughout their cities. All of this happened nearly 2,000 years ago when most of the world was still figuring out basic plumbing. The precision required was mind-blowing. A tiny miscalculation in the slope and the whole system would fail. But the Romans didn't just build these things to last a few decades, they built them for eternity. Some aqueducts are still functioning today, delivering water just like they did when toga-wearing engineers first switched them on. That's 2 millennia of continuous service without a single software update or maintenance call. The engineering behind these water highways required mathematical calculations that would make modern engineers sweat. Every arch, every gradient, every turn had to be perfect. Makes you wonder what else they figured out that we're still trying to match today. Speaking of things that lasted forever, the Romans didn't stop at bringing clean water into their cities. They also had to figure out how to get the dirty stuff out. While Rome's aqueducts brought clean water into the city, someone had to figure out how to get all that dirty water back out again. Enter the Cloaca Maxima, which sounds fancy, but basically means the really big drain. This massive sewer system became one of Rome's most important pieces of infrastructure, even though nobody wanted to talk about it at dinner parties. Built around the 6th century BC, this underground network started as a simple drainage ditch to keep the Forum from turning into a swamp. But Romans being Romans, they couldn't leave well enough alone. They expanded it into a sprawling system of stone tunnels that could handle both rainwater and human waste from across the city. The main tunnel was so big you could literally row a boat through it. Some of these passages were 12 feet wide and over 10 feet tall. Workers built them using massive stone blocks fitted together without mortar, creating arches that distributed weight perfectly. The engineering was so solid that major portions still function today, nearly 2,000 years later. Here's the brilliant part, though. The system prevented both floods and disease outbreaks that plagued other ancient cities. When heavy rains hit Rome, water had somewhere to go instead of backing up into streets and homes. Meanwhile, waste got carried away from populated areas instead of festering in the summer heat. The Cloaca Maxima emptied directly into the Tiber River, which wasn't great for downstream neighbors, but kept Rome itself surprisingly clean. This massive drainage network became the template for urban sanitation systems across the empire and eventually inspired modern city planning. But staying warm and comfortable required completely different Roman innovations that worked underground in an entirely different way. After building massive aqueducts to bring water into Roman cities, engineers faced another challenge. How do you keep everyone warm during brutal winters? Well, they invented something that would make modern heating contractors jealous. The Hippocos system was basically ancient central heating, but way cooler than anything your house has. Romans figured out how to heat entire buildings using nothing but fire, stone, and some seriously clever engineering. No electric fans, no gas furnaces, no complicated thermostats that nobody knows how to program. Here's how it worked. They'd build a furnace outside the building and burn wood or charcoal in it. Hot air and smoke would travel through a network of channels built right into the walls and under the floors. The floors were raised on small stone pillars, creating a hollow space underneath where the hot air could flow freely. These heated floors would warm the rooms above, turning freezing stone buildings into cozy living spaces. But the Romans didn't stop there. They also built vertical channels inside the walls themselves, letting hot air rise up and warm multiple floors. The whole system worked purely on the natural flow of hot air. No pumps, no electricity, just physics doing its thing. Roman bathhouses used hypocausts to create different temperature zones. You could move from a cool room to progressively hotter areas, just like a modern spa. Some wealthy Romans even had hypocausts in their private homes, which was basically the ancient equivalent of having a luxury heating system. The crazy part? Some hypocaust systems in Europe still work today, nearly 2,000 years later. That's Roman engineering for you. Speaking of Roman durability, wait until you hear what they did with flowing water to power entire industries. While Romans mastered moving water through their incredible aqueducts, they discovered something equally brilliant about harnessing that flowing water for actual work. Enter the water wheel, basically the ancient world's answer to free labor that never complained or asked for breaks. These weren't your backyard decorative wheels either. Roman engineers built massive wooden contraptions that could tower 20 feet high, positioned strategically along rivers and streams. The concept was beautifully simple. Flowing water hits the paddles, wheel turns, and suddenly you've got serious rotational power to work with. The real genius lay in wheel design. Undershot wheels sat partially in the water, getting pushed by the current flowing beneath them. But here's where Romans got clever. Overshot wheels received water from above, using both weight and flow for maximum efficiency. These beasts could reach 70% efficiency, which honestly put some modern machines to shame. What did they power? Grain mills became the obvious choice, grinding wheat into flour for bread that fed entire cities. Then there were sawmills cutting timber for construction projects, hammers for metalworking, and even mechanisms for crushing olives into oil, all without burning a single piece of coal or connecting to any power grid. The engineering required serious mathematical skills too. Romans had to calculate water flow rates, gear ratios, and power transmission, essentially creating the first industrial complexes along riverbanks throughout their empire. Some wheels operated continuously for decades, requiring only occasional maintenance and repairs. But water wheels represented something bigger than just machinery. They showed how Romans thought about energy itself, finding ways to capture natural forces and put them to productive use. This mindset would eventually inspire medieval mills and even modern hydroelectric dams. Speaking of Roman innovation with lasting materials, though, their concrete formulations created structures that make today's construction look almost temporary by comparison. While Romans built impressive aqueducts and sewers, their secret weapon was actually what held everything together. Roman concrete wasn't just another building material, it was basically ancient superglue that laughed in the face of time. Here's where things get interesting. Most people think concrete is concrete, right? Well, Romans had discovered something that modern engineers are still trying to fully understand. They mixed lime with volcanic ash from Mount Vesuvius, creating a chemical reaction that actually got stronger underwater. The weird part is that while our modern concrete starts cracking after 50 years, Roman concrete has been sitting in seawater for 2,000 years and is still rock solid. The Romans didn't have cement trucks or electric mixers. They combined their volcanic ash with lime, water, and chunks of stone using nothing but muscle power and wooden tools. But the real genius was in the ash itself. When seawater hit Roman concrete, it triggered a process that kept building tiny crystals inside the mixture, basically self-healing any cracks that tried to form. This stuff was so durable that Romans could build massive domes like the Pantheon, which still has the world's largest unreinforced concrete dome. They constructed harbors that have survived countless storms and earthquakes. Some Roman bridges are still carrying traffic today, supporting cars and trucks the builders never could have imagined. Modern scientists have spent decades trying to recreate this formula, but volcanic ash from Vesuvius isn't exactly easy to ship worldwide. Makes sense, right? The Romans had stumbled onto construction gold, and they used it to build an empire that would literally stand the test of time. Speaking of building things that last, Romans weren't content with just mixing perfect concrete. They also mastered the art of digging through solid rock to reshape entire landscapes. When Romans decided they wanted to turn a swampy lake into farmland, they didn't just complain about it. They grabbed their pickaxes and started digging underground tunnels that would make modern engineers sweat just thinking about them. The Fucine Lake project stands as one of their most ambitious feats. Picture this massive lake in central Italy that kept flooding valuable agricultural land. The Romans looked at it and said, "Nope, we're draining this entire thing." Their solution? Dig a tunnel over 3.5 miles long straight through a mountain. But here's where it gets wild. They didn't have GPS or laser levels or any fancy surveying equipment. These guys used basic geometry, wooden measuring sticks, and pure mathematical brilliance to dig from both ends of the mountain simultaneously. The margin of error when the two teams met in the middle, just a few feet. That's insane precision for hand tools and torchlight. The engineering challenges were brutal. Workers had to deal with cave-ins, flooding, and suffocating air quality deep underground. They developed ventilation shafts, wooden support systems, and drainage techniques that kept the project moving forward for over a decade. Then there's the sheer human effort involved. Thousands of workers, many of them prisoners and slaves, chipped away at solid rock with hammers and chisels. No dynamite, no mechanical drills, just human determination and clever problem solving. What's remarkable is how these tunnel techniques spread throughout the empire. Romans used similar methods to drain mines, create underground aqueduct sections, and build passageways through hills. The skills they developed became the foundation for underground construction that lasted centuries. Speaking of lasting construction, Romans had another space-saving trick up their sleeves that transformed how people moved through tall buildings. Ever tried walking up a normal staircase in a cramped medieval tower? You'd probably end up with your head through the roof or your feet dangling in midair. Romans figured this out early and came up with something brilliant: spiral staircases that twisted upward like a stone tornado. These weren't just pretty architectural features. They solved a massive space problem that had been driving builders crazy for centuries. Traditional straight staircases ate up enormous amounts of floor space, which was pure gold in crowded Roman cities. But wrap those steps around a central column in a tight spiral, suddenly you're moving people up multiple floors without sacrificing precious room below. The engineering was surprisingly tricky. Each stone step had to be carved to exactly the right angle and depth. Too steep and people would tumble backward, too shallow and the staircase would sprawl outward like a lazy snake. Roman architects calculated the perfect rise and run for each step, creating comfortable climbs that could handle heavy foot traffic day after day. Trajan's column shows off this technology beautifully. Inside that towering monument, a spiral staircase winds up through the center, letting visitors climb to the top without any external supports or awkward landings. The steps are worn smooth by nearly 2,000 years of feet, but they're still perfectly functional. Then, there's the defensive advantage nobody talks about. Castle builders later discovered that spiral staircases gave defenders a huge edge during attacks. Enemies climbing up had their sword arms pressed against the central column, while defenders above could swing freely. Smart Romans probably knew this trick long before medieval knights figured it out. But Romans weren't the only civilization working with clever construction techniques. They also mastered ways to multiply human strength using simple mechanical principles that would revolutionize food production across the empire. From spiral staircases to kitchen innovation might seem like a big leap, but Romans were obsessed with making everything work better, including their food production. Ever tried squeezing grapes by hand? Your fingers cramp up after like 10 grapes, and you get maybe a few drops of juice. Now multiply that by thousands of grapes needed for wine production across an entire empire. The Romans had a brilliant solution that didn't require any fancy machinery or electricity. The screw press changed everything. This wasn't some complicated contraption, just a massive wooden screw that workers could turn to create incredible pressure. Think of it as the ancient world's hydraulic press, but powered entirely by human muscle and clever engineering. Here's where it gets interesting. The screw mechanism multiplied force dramatically. One person turning the handle could generate the crushing power of dozens of people stomping grapes. Romans used this same principle for olive oil production, which was absolutely crucial since olive oil wasn't just food. It was soap, lamp fuel, and medicine all rolled into one. The beauty lay in its simplicity. Wooden frame, metal screw, heavy pressing plate on top. Workers would load grapes or olives into a basket, position it under the press, and start turning. The twisting motion slowly lowered a heavy wooden plate, squeezing out every drop of precious liquid. Some traditional wineries still use screw presses today, nearly 2,000 years later. That's staying power. The Romans basically perfected a technology so efficient that modern producers haven't found much reason to change it. But crushing grapes was just one part of Roman daily life. They also needed to know when to harvest those grapes in the first place, which meant keeping track of time itself. Ever been stuck wondering what time it was while traveling through ancient Rome? Well, the Romans had that covered with something pretty ingenious. They created portable sundials that could slip right into your pocket. These weren't just random pieces of metal with lines scratched on them. Roman engineers actually did the math to make these things work properly. They calculated sun angles for different seasons and even adjusted the markings for various cities across the empire. That's some serious geometry without a calculator in sight. The basic idea was simple enough: stick a small rod or piece of metal upright, and the shadow it cast would point to the time. But here's where it gets clever. Romans made different versions for different latitudes. A sundial that worked perfectly in Rome might be completely wrong in Britain, so they had to customize each one. Some of these pocket timepieces were tiny works of art. Craftsmen carved intricate designs around the time markings, turning a practical tool into something beautiful. The wealthy Romans especially loved showing off their fancy portable sundials at social gatherings. The really smart part? No moving parts to break, no batteries to die, and they lasted for decades. You just needed the sun to cooperate, which was usually fine in the Mediterranean climate. Sure, cloudy days were a problem, but that beat having no way to tell time at all when you were miles from the nearest public sundial. These little devices spread throughout the Roman world, helping merchants, soldiers, and travelers stay on schedule. And the weird part is, some of these ancient pocket sundials were more accurate than early mechanical clocks that came centuries later. Speaking of staying comfortable while traveling, Romans had another brilliant solution for making life more pleasant. While Romans were mastering underground heating with hypocausts, they discovered something brilliant. Why not heat entire public bathhouses? These weren't your average neighborhood pools. We're talking about massive social complexes that could pack in thousands of Romans at once, all without a single electric heater or modern pump system. The genius lay in combining their hypocaust technology with recycled aqueduct water. Hot air traveled through underground channels, warming floors and walls of enormous bathing halls. Romans created different temperature zones, scalding hot pools, lukewarm areas, and cold plunge baths. Want a steam room? They had those too, naturally heated by the same underground furnace system. But here's where it gets interesting. These bathhouses weren't just about getting clean. They became the social media of ancient Rome. People came to gossip, make business deals, exercise, and show off. Rich senators soaked next to regular citizens, creating a surprisingly democratic space in an otherwise hierarchical society. The engineering behind this comfort was remarkably simple, yet effective. Slaves fed wood into massive furnaces, heating air that circulated through brick channels beneath marble floors. Water flowed in from aqueducts, got warmed by the system, then drained away through sophisticated sewers. No electricity, no complex machinery, just clever use of heat, gravity, and water flow. Some of these ancient bathhouses were absolutely enormous. The baths of Caracalla could hold over 1,600 bathers simultaneously, covering 27 acres. The whole complex included libraries, gardens, and exercise areas, making it more like a modern spa resort than a simple bath. While Romans were revolutionizing public bathing, they were also perfecting another everyday technology that required incredible precision and artistry. Their approach to pottery would create tableware so durable it still amazes archaeologists today. When Romans wanted fancy dinnerware, they didn't just grab any old clay pot. They created something called Samian ware. Pottery so shiny and perfect it made regular dishes look like mud. This wasn't your grandmother's ceramic collection either. We're talking about tableware that could survive being buried underground for 2,000 years and still look gorgeous when archaeologists dig it up. The secret? Pure Roman obsession with getting things right. They mixed powdered minerals into their clay, then fired everything at temperatures hot enough to make modern potters sweat. No electric kilns, no digital temperature controls, just skilled craftsmen who knew exactly when the flames were perfect. The result was a glossy red finish, so smooth it practically glowed. But here's where it gets interesting. This pottery wasn't just pretty, it was tough as nails. Roman families used these dishes every single day, and they held up better than most modern plates. Drop one on your kitchen floor today, and you'd probably cry. Drop Roman Samian ware and it might just laugh at you. The Romans were so proud of this stuff, they traded it across their entire empire. From Britain to Egypt, everyone wanted that signature red shine on their dining table. Archaeologists can actually track Roman trade routes just by following broken pottery pieces. Makes sense, right? Quality goods travel far. Then there's the manufacturing process itself. Workshops employed dozens of skilled potters who stamped decorative patterns into the clay before firing. Each piece was basically handcrafted art you could eat off of. Speaking of Roman innovations that moved things smoothly, their engineers also figured out how to reduce friction in ways that would make modern mechanics jealous. Ever wonder how the Romans managed to build those massive ships that could carry hundreds of people without modern ball bearings? Well, they basically invented their own version. These ancient engineers figured out that rolling beats sliding every single time. The Romans created roller bearings using wood and bronze, simple materials that solved a huge problem. When you're trying to move something heavy, friction is your worst enemy. But here's where Roman cleverness shines. Instead of dragging heavy objects across surfaces, they made them roll on cylindrical pieces. Lake Nemi held two enormous ships that were basically floating palaces for Emperor Caligula. These weren't your average fishing boats. We're talking about vessels over 200 feet long. The Romans used roller bearings in the steering mechanisms and winches of these giants. Makes sense, right? When you're trying to turn a rudder that weighs as much as a small house, you need all the mechanical advantage you can get. But the genius didn't stop at ships. Roman engineers placed these roller systems in cranes, heavy doors, and lifting equipment throughout the empire. They understood something that took humanity thousands of years to perfect. Reducing friction makes everything easier. The bronze rollers were placed between moving parts, just like the ball bearings in your car wheels today. No electricity required, just smart engineering and good materials. Some of these bearings were found perfectly preserved in shipwrecks, still smooth after nearly 2,000 years underwater. What's really wild is how this simple concept became the foundation for almost every machine we use today. Your bike, your car, even your office chair, they all use the same basic principle those Roman shipbuilders figured out centuries ago. Sometimes the best solutions are surprisingly simple,